Hi guys, welcome to Learn Electronics Repair. I have an oscilloscope from Fnirsi to look at today. This was sent to me to review, so I didn't pay for this item, but I'm not being paid to make this video. I have free editorial control, so whatever my opinion is of this, it will be my honest opinion, okay? So this is a scope meter, oscilloscope multimeter, 50 megahertz dual channel, model 2C53T. Says 4.5 digit multimeter, okay, 50 megahertz bandwidth, intelligent anti-burning, okay, firmware upgrades. We have a little bit more information on the back of this, but I think we probably would better just look at the manual because it's probably a bit easier to read, okay? So here is the scope meter. Comes in a very nice protective case, clearly meant for portable use, although I'm sure you could use this on the bench just the same. Fnirsi. We have fairly standard multimeter leads, scope probes, 2 of them, one of the BNC to crocodile clip leads, and a charging cable, USB-C. Instruction manual in Chinese and English. And let's look at the scope. And I've just noticed actually, so this is part of the case, just sits over there. That stops the leads and things scratching the oscilloscope screen. I like that actually. That's well thought out. And our scope meter. It has some weight to it, not overly heavy, but feels quite chunky. Okay. Multimeter connections and connections for the scope probes. DDS, so this will be a signal generator, 2 inputs. These are quite nicely done, so they recessed fairly well into there. Let's just see. Yeah, obviously this needs to be exposed so you can actually fix it on. But considering this is a handheld scope meter, so this can be connected to live equipment without damaging anything. But bear in mind, you connect this to live equipment, this could be live. So you want that in a position where it's not easy to touch, okay? And I think that's done quite well, actually. Let's see if this came with the batteries charged. Asking me for language, English. Fairly obvious. Scope, signal generator, settings, multimeter. Okay. So this looks very similar to other models of the Fnirsi scopes I have had. The main point with this one is the 50 megahertz and dual channel. Do we press select? No, we press enter. And we have like an analog cum digital meter. Yeah. Oh, yeah, with the extra digit. So let's have a quick look first to see how much this costs. It's always nice to know the price of this. And then we'll test the multimeter. I'll test the main things I'm interested in. So the things that usually multimeters struggle with are the bleep test on the diode and resistors and continuity, measuring low value resistors. And I like to have a multimeter which will read down into very low currents and low voltages, so we can see how well this works in those scenarios, and then we'll have a look at the scope and finally a quick look at the signal generator. Here we are on Fnirsi.com, so you can see the 2C53T is an upgraded version of the 2C23T, which I have reviewed, so I'll link that review to this one. The price $77. although that is for the standard kit, the full set 83. So really not much difference, to be quite honest. What do we get for the extra few dollars? Well, this is the standard kit, and this is the full set. So we get an extra scope probe. That's the basic difference between the two. This new version, as well as the higher bandwidth, has additional maths operation. That's really quite useful because it means you can probe high voltage signals more safely, improve measuring range, and the 4.5 digit multimeter we can see, compared with the original, which was the 10 megahertz version, the one I looked at before, that has the 4 digit multimeter. So a number of improvements, to be quite honest. Okay, so we know what this costs. Let's try it out. These are the provided leads. They're fairly standard, to be quite honest. These come off, and we can see these are the needle points, so these are rather nice, better than the kind of blunt ones you usually get with a multimeter. I could use these. Let's have a quick look at settings. Sound and light, language, start up on boot. Oh, so we can choose to boot into whichever setting we want. That's quite nice. Auto shutdown, yeah. USB sharing, not sure about that. We can maybe try it. So that's the basic settings in here. I'll turn the bleeper up so you guys can hear it better. That is quite loud now, but better for you guys, I would say. Let me know down there. Yeah. And it says version 1.01, so that's what I have here. That's what they provided me. Hold the menu button to come out of there. So multimeter, what do we have? Well, the thing I always want to try first, continuity diode mode bleeper, okay? So it's quite responsive. The bleep comes before the display, which is normal. Okay. How about diode? Let's see. Well, it doesn't work in the continuity range. I guess I have to go to diode. It didn't actually mention in the manual, so I had to figure it out. It wasn't too difficult. So this C1, C2 move button, we can see here it says on off, which I think really should mean continuity, and that changes to diode. So we can see this is switching between ohms and volts. Okay, it flashes millivolts and volts, kilo ohms and ohms. Okay, so for continuity on ohms, we get a continuous bleep. Okay, if we measure a diode, it won't measure on the ohms range. We go to diode range, yeah, and then it will measure, of course, 0.539, but we don't get a blip and we don't get a bleep, which is a bit of a shame because that is very useful when fault finding. I've shown this numerous times. So that is the Mr. Bleep test, which it doesn't pass, but it does measure. Let's look at some low value resistors. Typically a multimeter won't read very well on low value resistors. Even my fluke meter doesn't read them properly. So this is actually like two resistors in series. So we have 0.22 and then another 0.22. So we have 0.44 of an ohm. So I'm in diode range. I need to go back to ohms range, and we'll also try this on resistance range as well. So that's saying 1.09 and 0.29, yeah? So you can see, if we minus the 0.29 from that, it thinks that this is about 0.8 of an ohm. And obviously that's more. Let's go to ohms range though. So can we set this into manual ranging? No, it looks like it's auto ranging only. So that means get a good connection on it to be sure. 1 ohm, so it's a 0.22. That means 1.32, which is a 0.44. Now, admittedly, my fluke meter doesn't read this very well either, even on low ohms range, which I can calibrate, by the way, on this one, so I can actually hit the calibrate button. Okay, we measure this resistor, so this should be 0.22. It reads 0.1, and that should be 0.44. It reads 0.3, so it's closer, but it doesn't read them correctly. You really need a proper milliohm meter to measure these things, so that's not a problem particularly with this multimeter. It's a problem in general with multimeters on very low resistances. Let's just try a few higher ones. 10 ohms is reading 10.1 now, so that reads just fine. I'm not sure what this is trying to show me here, how I refresh that. Well, select and go back to it, that refreshes it. Interesting, so it's giving me 10.21 ohms as the maximum, 5.105 as the mean, and 0 as the minimum. And now it changes. I have to say I'm not totally sure what that is intending to show me or how I would use that. Okay, here's a 47k resistor. Just try this one. 47k, and although it's on auto ranging, I must admit this does auto range very quickly. And lastly, a 10 mega ohm, which is the highest value I have here. 10.5. That's pretty good, to be quite honest. A lot of multimeters will read 11 or so, plus these are not high tolerance or close tolerance resistors particularly, so we can't say exactly what that should be. But I'd say that was good enough. Capacitors. As is normal with a multimeter, I expect this to take longer to read the capacitance the higher the value. So that's a 100 nanofarad, it's very close. Low value capacitors, really multimeters can't read them or not very well. So for example, this is a 12 picofarad. I'm interested to see if it can actually read this. I wouldn't be surprised if it can't, because often multimeters are not very good at this anyway. Well, actually it reads and says it's 6 or 7 picofarads, which, to be quite honest, these are really not close tolerance at all, so you may well be reading that quite well. What does my fluke think of that? Well, it doesn't want to read it at all, so points to this one for that, yeah? And then when we get to large value, they just take quite a while to read, at least on my fluke and other multimeters I've tried. So let's have a look at this one. This is a 1000 microfarads. Okay. That is pretty quick. Look at this one. This is the same capacitor. So it will read it, but it takes a very long time. So kudos again for that. Let's try something big like a 4700. Again, it takes a little while, but this is much slower. Okay, so that is quite acceptable, I think, for a multimeter. If you want to measure capacitors instantly, get a dedicated capacitance meter, which is basically the reason I own one. But for a multimeter, that is one of the better ones I've seen for sure. What's the lowest current and voltage this can read? Well, it goes down to 1 microamp. We can test this by measuring the current draw on a CMOS battery on the motherboard. Okay, so I've put this into the milliamps socket. Let's have a look. Red lead on the battery and push back on the little tab with the black lead. And typically a motherboard from the CMOS battery is drawing between about 1.8 microamps up to about 10 depending on the motherboard, but usually less than 5. Let's have a look. And that doesn't show anything. Okay. Doesn't show anything. I'll just measure the voltage to check. Okay. So yeah, there's over 3 volts, and so that's fine. Now, my fluke meter also is not good at this. But this is the Zoe meter, and this is why I keep meters like this one, my little Aneng meter. But this is pretty much replaced that now because the screen's much better for you guys to see. We'll try this. I'm on milliamps. Again, we'll connect to the milliamp socket. So let's try this one. So this should read down to a microamp again. And we don't. We do, look, 1 microamp. One, and then put this on 2 or 3. So it's suggesting it's about 1 or 2. Let's go to microamp range on this one. Yeah, 1.94 microamps, 1.96. So no kudos on that one, it won't read it. But as mentioned, neither will this. Okay, so a reasonable all-rounder, doesn't do the bleep on diode test or the blip, struggles with very low currents, but it was fast when it was reading capacitors, much faster than my other multimeter, and it was nice on resistors apart from very low value resistors, but again the other one won't read them anyway. Okay, so multimeter I think is like a, you know, reasonable all-rounder there. Okay, let's look at the oscilloscope. Okay, the screen is quite bright and visible actually, so we have yellow and cyan, which are the normal colours you would expect to have. This does have a little stand like so, but I'm guessing for you guys you can probably see it better like that, apart from when I have the overhead lights reflecting in it. Let's just see if we can get a good viewing point for you guys. Yeah, that's pretty good. So first of all, let's look at some very small waveform. The motherboard isn't powered up. This is the real-time clock crystal. And it has it. Yeah, it has it. So 33.3 kilohertz. It's saying that's very close for a real-time clock. Duty cycle 50%. 39 millivolts. Yeah, that's about what you'd expect. So that works quite nicely. That's with the probe on 10 times, okay? Quite happy with that. Let's power this up and then we'll look at, for example, the VRMs. So let's have a look at the pulses coming from the VRMs on the power supply for the processor, okay? So switch it on. booting up. Let's see what we have. I have the ground, by the way, attached from the other scope probe. I often do that actually, so that I don't have this one effectively restricted by a short lead. In fact, quite often I will just take that off so it's not flapping around my wrist and connecting me to whatever ground that's connecting me to, which might not be the best idea. So we have 3 MOSFETs here, high side and 2 low side. I think this is probably the output, or it could be ground, depends on which way these are actually physically mounted. Yeah, so that was the output, so we hit auto. Just think about, oh look there, that's not bad at all. Yeah, so we have some stray signal being picked up from the other scope probe, which looks like it's actually kind of some sort of ringing where the thing switches, but that's worked pretty well. Let's try something else. I'll give it a bit of a challenge now, okay? My RF generator DIY one is kind of in bits at the moment, so after the weekend this will be put together. In actual fact, when I put this together, you'll see this then. We'll just test this oscilloscope on it after the weekend and see how well it works at high frequencies. Okay, but that's another video first. So we have here a switch mode power supply, and we're going to look at the waveform that's driving this transformer. Okay, now this could be quite high voltage actually. I'll just use the one channel, so channel 2 I can switch off. Here we just hit channel 2. Press this OK button or pause play button. That is now switched off. This is channel 1. We can see we're on times 10. We can change the coupling here from AC to DC. I'll put it on to DC actually. Let's see how it works. Okay. We have display mode in here, XY. To show that I need 2 signal generators. As I've shown you, one of mine's kind of in bits at the moment. So I will, again, when we look at the frequency response, I'll try pushing this up to the 50 megahertz. We can also have a little play with the XY as well. Okay. Cursor measurements. So this is mathematics. Okay. Parameters. So this is what you can display on the screen. Voltage peak to peak, duty cycle, frequency is set at the moment, so we can display a lot of different parameters. Channel 1 settings, channel 2 settings, and trigger settings. Okay, so that's what's actually in the menu. But I'm going to try the auto on this. Now, this power supply, when it has no load attached, which at the moment it doesn't have, it goes into kind of like a pulsed mode. So it's just pulsing the transformer sporadically to just hold the voltage at 12 volts on the output. But because there's no load, it doesn't have to do it very often. Yeah. So sometimes it's hard for the oscilloscope to trigger on this. I'm interested to see how well this works. I'll move the cursor a bit further down, I think. Another thing I noticed with this is if we switch it off and switch it back on again, you can obviously set it to boot the oscilloscope. At the moment it's just set to go to the menu. But look, it's remembered the settings it was on. Okay, so that's nice, that's handy, I like that. Yeah, you can see I'm using select to choose whether to move the cursor, whether to change the voltage. Okay, it's fairly intuitive to use this actually. Now let's see if we can trigger on this. Bear in mind, my ground lead is attached to the negative end of the large capacitor. Well, that is not safety ground. That is hot ground. That is a floating voltage, what they call half mains potential. But what they actually mean is all of the mains potential for half of the time depending on the sine wave. Yeah, so it's not safe to touch this with your finger. And this is what I'm mentioning about this. So the metalwork here will be floating at a high voltage. But I quite like the design of this because it's not easy to touch that, and there's nothing else exposed on here that you can touch. Okay, so this is as safe as you can get really for this type of work. Bear in mind, there is always some risk involved in working on high voltage equipment. You need to understand what you're doing. If you understand it, you can do it in relative safety, okay? But let's see what the scope makes of this. You could not do this with a bench oscilloscope that was earthed or grounded, by the way, because you would just blow the power supply up, because you're connecting this floating potential to ground. And that floating potential is live or neutral, alternatively coming through the bridge rectifier, okay? So I've switched the power supply on, and I think you can see, look, occasionally flicking on the screen. Let's hit auto. We'll hit the auto button, see what it thinks of it. And this is what a lot of scopes do because of this sporadic waveform. It's hard to lock onto it. And as best I can see, you can see that there is a pulse there sporadically, but you can't really lock onto it. Okay. There. I'll switch the power supply off. Ah, you can see it there, look. Eventually it will stop. Now let's connect a load to the power supply. Okay, so I've attached a 20 ohm resistor. This is a 12 volt supply, so that gives a bit more than half an amp. If it was a 24 ohm, it would be 500 milliamps. It's 600 odd milliamp load on here now. So the power supply now should not run in that burst mode. It should run continually, and this should now be able to lock this quite easily. So let's have a look. So power on, and it's running. Auto. And there we have it. So it's locked and triggered. There's a bit of jitter, but the jitter is in the power supply. It's not jitter in the oscilloscope, because the power supply is constantly varying the output slightly to basically maintain the output voltage. 309 kilohertz, yeah, you can see. It says the duty cycle is 100%. I think it can't really understand the rather strangely shaped waveform, but we can clearly see that the power supply is running, and this is set to 100 volts vertical. So we have 1, 2, 3, about 380 volts high, yeah, and that worked nicely. Now switch off, it's gone. So I need to sum this one up. I would say it's a good all-rounder, really. This is obviously portable test equipment, and I think when you're out in the field, this will do what you want it to do. If you have some complex fault, well, you're probably going to take the board to the workshop anyway, and in the workshop, well, you probably have your bench equipment, yeah, but it's not bad as an all-rounder, this one. As I mentioned, after the weekend, I'll put the RF generator back together, and then we'll try this. So we'll try pushing this up to 50 megahertz and above to see how well it responds. Often I find it will display a sine wave at even higher frequencies than it's rated. Be interesting to see that. However, I do believe if you're interested in a handheld oscilloscope or scope meter, this is on the par with a lot of other ones I've tested. On the plus side, it has the XY facility, which we will try when we have 2 signal generators set up on the bench, 50 megahertz. And from what I've seen of Fnirsi equipment, generally speaking, it will display a waveform and show you the frequency at the rated specification. With this one, we're going to find out soon. Hope you enjoyed that anyway. In the comments below, guys, let me know what you think. And I'll look forward to seeing you all soon again on Learning Electronics Repair to have a second look at this. And also, hopefully you enjoy my repair videos too. Ciao for now, guys.